Hey guys, Dean Chase here with another geometry lesson for you. Hope everybody's doing good. Let's go ahead and start this thing off with a word of prayer. Dear Father, I want to thank you for saving us, Lord. I want to thank you for all you do. I pray you'll be with my students, bless them, help keep them healthy, Lord. We love you. In Jesus' name we pray, amen. Alright guys, so today we're going to be looking over lesson 3.6. This is page 190 if you're working on the book I'm working out of, and we're going to learn how to prove theorems about perpendicular lines. Okay, so let's go ahead. Theorems we're starting off with, theorem 3.8. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Okay, so what that is saying, if you have a linear pair that is made up of two congruent angles, the lines will be perpendicular. Okay, they intersect to form perpendicular. So G and H are perpendicular. Theorem 3.9. If two lines are perpendicular, then they intersect to form four right angles. So if A and B are perpendicular lines, they intersect and form four right angles. Right angle 1, 2, 3, and 4. Okay? So, here we go. In the figure, angle 1 and angle 2 are congruent. Okay? Congruent means they're equal, they're the same in every way, right? What can you conclude about the measure of angle 2? Well, since angle 1 and 2 form a linear pair, what can you conclude about the measure of angle 2? You can conclude that the measure of angle 2 equals 90 degrees. Okay? Because a linear pair with two congruent angles would mean that both the angles have to equal 90 degrees. Hope that makes sense. We just learned about it in the last slide. Let's keep going. Theorem 3.10. If two sides of two adjacent angles are perpendicular, then the angles are complementary. Okay? So if ray BA and ray BC are perpendicular, angle 1 and angle 2 are complementary, meaning that they add up to equal 90 degrees. Okay, we're actually going to prove this theorem to be true in our next slide. So let's go ahead and do that proof. They want us to prove that if angle 1 and 2 are complementary, that ray BA and ray BC are perpendicular. So the first thing in a proof, we're going to go ahead and write our given. Okay, angle 1 and angle 2 are complementary. That was given to us, and the reason why, obviously given. Okay, now what do we know if two angles are complementary? We know that the measure of angle 1 plus the measure of angle 2 have to add up to equal 90 degrees by the definition of complementary angles. So let's just go ahead and write that down. The measure of angle 1 plus the measure of angle 2 equals 90 degrees by the definition of complementary angles. Okay, now we know that angle 1 and angle 2 equal 90 degrees. Let's define what the measure of angle 1 and the measure of angle 2 add up to be. And they add up to equal angle ABC. Okay? So the measure of angle ABC equals the measure of angle 1 plus the measure of angle 2. And that is just simply the angle addition postulate. Okay, so now we know that the measure of angle 1 plus the measure of angle 2 equal the measure of angle ABC. We also know that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So we can actually substitute in 90 degrees right here using the substitution property of equality. So the measure of angle ABC equals 90 degrees by the substitution property of equality. Okay. Ultimately, we're trying to prove that line BA and line BC are going to be perpendicular. Well, here we show that the whole angle forms a 90-degree angle, which means that it is also a right angle, right? So the measure of angle angle ABC is a right angle, okay? And that would be the definition of right angles. Right angles add up to equal 90 degrees. are equal to 90 degrees. Okay, if a line angle is a right angle, it also means that the two lines that form it are perpendicular. So we can say our statement, or what we're trying to prove now, line BA is perpendicular to line BC. Okay, and that's the definition of perpendiculars, perpendicular lines. Okay, not a bad proof. I really hope proofs are starting to flow better for you as we keep going along, and the more proofs you read and the more proofs we practice, the better they'll make sense. So make sure you're looking at the examples in your book too, because learning proofs is just reading. It's kind of like history. The more history you read, the more depth of knowledge you have of history. The more proofs you read, the more depth of knowledge of proofs you're going to have. So make sure you're looking at both sets of examples, the ones I do and the ones that are in your book. Okay guys, let's go ahead and keep going. Theorem 3.11, perpendicular transversals theorem. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So, J being the transversal is perpendicular to H. That also means J is perpendicular to K because H and K are parallel lines. Okay, Theorem 3.12. Lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So here, P is a transversal and you have these two lines that are both perpendicular to P. We can actually say that M and N are going to be parallel. And we'd also know that since they're right angles, they're both equal to 90 degrees, which also means they're corresponding angles right here. These two angles would be corresponding angles on this transversal, which also means that those two lines would be parallel since they both equal 90 degrees. That's why that theorem works. Okay, let's go ahead and keep going. Determine which other lines, if any, must be perpendicular. Explain your reasoning. Okay, so first off, we know that line B and C are perpendicular because of this little symbol right here. That's given. So let's just go ahead and write that down. Okay, now we can actually prove that A and B are parallel lines because both of these angles are 75 degrees. And this is a transversal to these two lines, so this would be the corresponding angles theorem. Okay, so by the corresponding angles theorem, A is parallel to B. Okay, makes sense so far. If A is parallel to B, we can say that A is perpendicular to C, because if C is perpendicular to B, it's also going to be perpendicular to the other parallel line by the transversal theorem we just learned. So let's go ahead and write that down. So A is perpendicular to C by the perpendicular transversal theorem. That's all there is to it. Those are the two lines we could state are perpendicular, B and C and A and C. Okay, distance from a line. The distance from a point to a line is the length of the perpendicular segment from the point to the line. This perpendicular segment is the shortest distance between the point and the line. For example, the distance between A and line K is AB. So you have point A, line K. The shortest distance is AB because that's a perpendicular line formed with K. You will prove this in chapter 5. Okay, the distance between two parallel lines is the length of any perpendicular segment joining the two lines. For example, the distance between line P and line M, P and M, above is CD or EF because both of those are the perpendicular segments between the two lines. Okay, so let's go ahead and do our last example and get on out of here. You know what I'm saying? Okay, so what is the distance between the two parallel sides of the tabletop? So it's pretty obvious which two sides are parallel, this side and this side. Let's go ahead and color them both purple. The main reason we could tell that is these two slopes definitely don't match up. Okay, so to find the distance between them, we have to find the perpendicular line that connects them both. And the way we can do that is we can actually find the perpendicular slope, which the slope of this line is, let's go ahead and find out the slope of the original. Slope of purple, I'm just going to write it in purple, or M for slope, is going to be up 1, 2, 3, and over 1, 2, 3, 4. So 3 over 4 was our original slope. Okay, positive slope, right? Left to right is going uphill. Okay, so we know that our new slope is going to have to be negative, and it's the reciprocal of 3 over 4, so 4 over 3. Negative 4 over 3. And the way we're going to find the perpendicular line that's going to connect the both of them is just pick a point. Let's go ahead with 0, 3. And we're going to graph this slope to form the perpendicular line. So it's going to go down 4, 1, 2, 3, 4, and over 3. 1, 2, 3. Look at that. They give you a point and a point already. That's so handy. Aren't they nice to us? So this is going to be the line that forms the distance between the two lines. So to find the distance, we know the distance formula, where d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so we just need to plug in our points we're given here into this formula to finish solving this. So d is going to equal the square root of, let's call it x1 0 and x2 3. 0 minus 3 squared plus y1, y2, 3 minus 1 squared. Okay, so d is going to equal the square root of negative 3 squared plus 4 squared. Okay, d equals the square root of negative 3 squared is going to be positive 9 plus 4 squared is going to be 16. So d equals the square root of 25. So the distance equals 5. And we are done. I guess when I see those examples, I get a little exhausted just looking at them because I know the distance formula is going to take some time. But it's really not bad once you always remember the distance formula. And we need to really put that in our memory for use, guys. That's the whole lesson. Next, we're going to be taking the chapter test. So I hope you guys are all doing good. Behave yourselves. Please be good for my subs. And see ya!